Welcome to the Coldcast. I'm your host, Dr. Anna Johnson, and I'm Vice President of Corporate Development and Marketing here at United States Cold Storage. And today we have a highly anticipated episode featuring the Senior Vice President of Sustainable Engineering, Mike Lynch. Welcome to the Coldcast, Mike.
Anna, thank you.
I know, it's been a long time. I know.
I'm excited.
I know. I've only had one other person repeat, so maybe you'll be our next repeat guest.
Maybe.
We are very thrilled. I know you guys are super busy in engineering, and we're thrilled that you're able to join us. We're going to talk about just a host of different topics, including our sustainability goals, kind of what we learned at the board meeting in terms of how those sustainability goals are evolving, advancements in automation and innovation, our retrofitting, and then the latest trends in the cold storage industry.
Sounds great.
I know. So let's get into it. We only have 30 minutes. All right. So you're the Senior Vice President of Sustainable Engineering. So talk to me a little bit about how the engineering department is organized here at U.S. Cold.
Sure. I report directly to Larry,
Okay.
President and CEO of U.S. Cold Storage. And reporting up to me is Lisa Bettino, who oversees our safety. Dan Polstowait, who kind of oversees our engineering and sustainability. And Mark Schuchter, who oversees our automation group.
Okay.
So those three people report directly to me. So those three functions report up through engineering.
So if you think about 10 years ago, how were you organized 10 years ago?
10 years ago, it's probably two of us, right?
Right.
We've grown quite a bit since then. We now probably have 12 people
Okay.
reporting directly or indirectly to me. So the department's grown quite a bit over the last 10 years.
And so in what areas has it grown?
Well, sustainability didn't exist 5 years ago.
Right.
So we brought on Sarah. And working with Sarah is Henry and Haley. Haley's been with us for a while, but that department didn't exist 5 years ago. Automation, we have Mark Schuchter, and reporting up to him is Jesse Gasper and Alan Judah. And they're kind of supporting all our automation projects we got going on, which are quite a few. And then Dan. So reporting up to Dan is Paul Thomas. He's a little over a year in the job. He's running our project management side of engineering. And we have David Arnett and we have Jamie Thomas as our project engineers.
And so those are the people that really focus on the construction aspect of it.
From a building construction, but then there's Rob Moore, who's from a sustainability solar project. He's running a lot of the solar projects. So the department's grown quite a bit over the last 5 years.
And so why is engineering, when you think about engineering, why is it such a critical component of United States cold storage?
Well, the growth plans. We're about 350 million cubic feet. By 2035, we should be close to 600 million cubic feet. So we're the group that gets it done.
Right.
We have planners and thinkers, but when it comes to execution, the engineering department's the one that ultimately executes these projects, helps and supports the company's growth targets.
And in 2023, we kicked off, I think, 6 or 7 new projects.
6.
Yes. So how does that impact the engineering department?
Well, it keeps us quite busy.
Yes.
With 6 projects under construction, there's a lot of travel. There's a lot of planning. So there's a lot of coordination that has to take place between engineering, our subcontractors, our operations folks. So it keeps us quite busy. And we have standardized a lot of our activities to help us plan projects out so we could better manage what resources we do have.
And, on top of the construction projects, we also have all of the sustainability and solar projects that are going on.
Yes.
Right? Yes.
Yes.
So you guys man those as well.
We manage that as well. So there's a whole group of people managing that as well. And there's a lot going on in that field.
Yes. Talk to me a little bit about because again, you have sustainability in your title. So talk to me a little bit about the sustainability goals and kind of how you think about sustainability and how it's changed over the past few years.
Sustainability has really become a part of every decision we make these days. We've aligned ourselves with SWIRE's sustainability targets, and we have set targets for ourselves. 2 years ago, we had 2 targets. One was to be 30% renewable energy by 2030. That's changed. The board in April approved our goal to be 100% renewable by 2030. We still have our 100% or net zero carbon emissions target for 2050. That remains the same. The board approved that as well as in April. And the board approved 2 additional targets. One was to be our scope 1 and scope 2 carbon emissions to be 95% carbon free by 2045, and to be water neutral by 2028. So those 4 targets were presented to the board, were discussed and approved in April.
Well, so, I think if you think about some of our board members' perspective, they thought that we were farther ahead than a lot of companies were because, one of our largest costs and, emissions is energy, right? And so we consume a lot of energy. So, we were kind of already ahead in those areas. So is that what we're focusing on and continue to focus on, or are we looking at other areas of?
Short to midterm, we're going to focus very heavily on our scope 2 emissions, which constitutes all our electricity purchases. So the investments in solar, really our green energy plan is the vehicle, the strategy that's going to get us to be 100% renewable by 2030.
And so, we talked about solar and solar projects and the ones that we have underway. So what makes solar so attractive to a cold storage environment?
One is the resiliency of the solar. When the sun comes up, it's always generating electricity. The sustainable aspects of it, the fact that we don't rely on the purchasing of dirty power from the utility grid, and just the simplicity of it. It's not really mechanical in nature. It's a solar panel. It doesn't require a lot of maintenance. Maybe go out and mow the grass every month, but it's pretty reliable. Sun comes up, generates electricity. We use electricity, and we use it renewably.
And so, I think when you think about it, it gives us more of a reliable source, even though, whatever states and regions decide to do, we always are able to generate that power and really run off clean energy for as much as possible, even when there's not really the same infrastructure that might be available.
That is correct.
Yeah.
And one of the things we're seeing lately, probably in the last year, is the availability of electricity is becoming a problem.
Oh, what makes the availability a problem?
Well, AI. You're seeing all these data centers being built that consume a tremendous amount of electricity.
Right.
And a lot of the power companies don't have the power to support both that growing infrastructure and then new industrial infrastructure like ourselves. So we're looking at a property in Shafter, California. We're going to end up generating our own electricity on site because the power company doesn't have enough electricity at the moment to supply power to a new warehouse.
Well, it's interesting because, data centers for a long time were shrinking. So they were always shrinking their footprint because the technology had gotten so efficient. And so, they didn't need as much space to be able to generate the same amount of electricity. And now you're saying they're growing again.
Well, with AI, it takes a tremendous amount of computing power, and that generates a lot of heat that has to be cooled and refrigerated. So it takes a lot of electricity to cool these huge data centers that are popping up all over the place. And that's just a demand on the power grid that probably wasn't anticipated 5 years ago.
So I think from a sustainability perspective, we always think about, okay, well, how can we, Larry calls it green for green, but how can we save money? And, part of our sustainability strategy is really to protect the service levels for our customers and be consistent in our service levels, right? So that's really, if we can't generate the power, we need to be able to generate the power so that if something else fails, we have that adaptability.
Power is what keeps the products cold, keeps the rooms cold. So we're very heavily reliant on the availability of electricity, unfortunately.
So we talked a little bit about scope 1 and scope 2 emissions, and I think people are pretty familiar with those. Those are the ones that you directly have some influence on.
We have direct influence. Yes. It's electricity and it's employee travel. Basically, that's what constitutes scope 1 and scope 2. So
when you contemplate scope 3, how do we think about scope 3, and how do we address that? That's going to be a challenge because those are emission sources that we don't have direct control over. And I think, for our customers, I think, oftentimes we potentially could be a scope 3 for them. Correct. Even though technically we're worried about our scope 1 and scope 2, but we could come up as scope 3. So how do we think about that? Yeah, all the trucking that our customers use to bring product into and out of our warehouses. Yep. That's their direct scope 2. That's our indirect scope 3. We don't own those trucks. Right. We don't drive those trucks. We have very little control over how those trucks are used and how many. So the way we influence those is through really just influencing our customers.
We've been partnering up with customers that have partnerships and commitments to be renewable, sustainable in their driving through fuels and fuel economy. So patronizing those type of customers, influencing legislation, working with industry organizations like the GCCA is how we're going to try to reduce our Scope 3 emissions.
And I think, just in hearing us talk about sustainability and hearing, we'll get into a little bit more about, kind of how we're going to achieve those goals and how, we think about those goals. But I think, if anything, as customers, you should take away that we're trying to do things now that will impact us so that you can be confident that from a Scope 3 perspective, we have control over those, over the things that are, within our purview. So that way you don't have to worry about, we don't have control of this. We don't know what they're doing. We don't know where they're going. We have a plan. We know exactly where we're going, and you can have confidence in that.
We do.
I think that just creates a consistent service and experience for them.
And that's what our sustainable development strategy does. It takes a holistic approach at the company, looks at the various scopes. We have plans to affect and mitigate the ones we have control with, Scope 1 and Scope 2. The Green Energy Plan is really the vehicle that we're going to use to mitigate that. And then we're going to work with our customers and work with the industry to mitigate and reduce our Scope 3.
Well, talk to me a little bit about the Green Energy Plan. I know we have some big kind of pillars that it sits on. So, and we want to be, renewable energy by 2030. We want to have our SBTI goals by 2032. What is it? Hang on.
Scope 1 and 2 by 2032.
Okay, Scope 1 by 2032, and then renewable energy by 2030. So how, again, we changed those just in April. So how do we get there from where we are today?
Well, the Green Energy Plan is kind of a multifaceted strategy. So what we're going to look at is, first of all, become as efficient as possible. Use the least amount of electricity. And we're going to do that through investments in blast freezing technology, data science, a lot of these data pilots that we're doing in some of our warehouses to try to drive down our energy consumption. So we're going to try to make the pie as small as possible. The second strategy is going to be to invest and deploy on-site solar. And we have close to $200 million planned to deploy over the next 10 to 15 years on on-site solar.
Does every site have the opportunity for solar, or is it only in certain areas?
Yes and no. Theoretically, every site could put solar panels on the roof, but then you need to take into consideration the age of the roof, because you don't want to put a 25-year asset on a roof that may only have 5 or 10 years left. So we got to be cognizant of that. Where we have available land, underutilized space on the property, we would probably deploy a ground-mounted solar. And where we have roof space and where we can justify the roof space for on rooftop solar array, we're going to deploy rooftop solar arrays.
Okay. And then, you talked about blast freezing. So let's talk a little bit about the energy efficiency and how we're thinking about retrofitting those blast cells with the new technology. So what's coming online?
Yeah, there's some new technology that's hit the market probably the last 5 years. We've used quite a few of them already to great success. It's the QFM. It's a quick freeze module. It's very modular. Rather than filling a room full of, say, 30, 40, 50 pallets, closing a door and let it freeze for 72 hours. These are blast freezing cells that freeze the pallet at the pallet level. So when that single pallet's done freezing, you turn it off, you remove the pallet, you put a new pallet in. So you have a lot of granularity in how you freeze pallets. You're using room air temperature to draw air through the pallet, and we're seeing substantial energy savings through the use of these QFMs. So we have a plan to retrofit all our blast freezing cells, conventional blast cells, with QFM technology over the next 5 years.
I have a couple questions on this. So by doing the quick freeze method, so as soon as the pallet's ready, it can be taken out. Does that save time for the customer?
It definitely...
Is it quicker to freeze over time?
It's quicker to freeze.
Okay.
It allows a plant that maybe doesn't have blast freezing infrastructure to start blast freezing. So it's pretty easy to deploy, but it also increases our throughput. So we could actually blast freeze more for our customers.
Okay.
Our customers typically want pallets frozen within 36 to 48 hours. We're seeing this can easily be done through the QFMs. So it basically and it inherently increases the throughput. It doesn't necessarily improve the freezing, but it allows us to freeze more in a shorter period of time, thus using less electricity to do so.
And so you talked about retrofitting all of our blast cells. So how is it easy to do? Is it more difficult? Is it challenging? Or have they made it kind of the technology made it simple so that we can?
Well, that's the nice thing about these QFM modules is that they integrate into an existing pallet position. So we don't have to build rooms. We don't have to build additional refrigeration capacity. We just need to find space inside our freezers, install these QFM modules, and now you have blast freezing.
So technically it gives us a lot more flexibility to be able to offer blast freezing in places we typically wouldn't have thought about it before. So that's a great opportunity for customers because, you know, when you think about blast freezing, you think about where your production sites are. This post-production blast freezing could technically be anywhere that we need it. So I think that's a great point for customers to think about. So we talked about like how are we going to get there in terms of what we're achieving? What else are we doing?
Well, we're looking at entering into some power purchase agreements.
Talk a little bit about that because I think we might have talked about it before, but I don't know if really people understand what power purchase agreements are.
And this is also part of our green energy plan. So we have energy efficiency, we have on-site solar. The next strategies we're going to deploy are green tariffs. So where we can enter into a supply agreement with a power company to supply us with renewable energy, we're going to do that. We're already doing it in Georgia. There's opportunities possibly in Pennsylvania, in Utah, and other states. So where we can enter into an agreement, instead of buying power from a coal plant, we're going to buy power from a solar array. And maybe we pay a little bit more for the electricity, but it's immediate to deploy, and it's becoming more prevalent. We're seeing that.
It might be a little bit more expensive, but in the long term, is it because it's a consistent cost you've already pre-negotiated? You kind of know what you're getting as opposed to the wild fluctuations with energy.
We know what we're getting. We can budget for it. We can enter into it and exit out of it as necessary. But it's a way to achieve our goals of renewable energy, 100% renewable energy, without having to make capital investments in solar arrays. So that's one strategy. The second strategy is going to be through power purchase agreements, where a investor builds a huge solar array, say in Texas.
I think there's one actually under construction in Atlanta,
there's quite a few
south of Atlanta right now.
Quite a few
massive,
across the country. So they build these massive solar arrays, and we agree to buy power off that solar array for a period of say 10 to 20 years. And all that power is renewable, it's clean. The terms are relatively long. We get the renewable energy credit that helps us offset our carbon. And again, we don't have to deploy capital.
You reap the benefits of it without using
it's
really
the capital.
just
a capital expense that we incur. And it's becoming more and more prevalent.
Well, this might be too technical a question for the Cult Cast, but you're generating solar energy. If they're generating it over time, how do we store it?
Well, batteries. That's a simple answer right now.
That makes sense.
You put the electricity into a battery. You charge it up like your phone. And when the sun goes down and the solar arrays stop generating electricity, you then discharge your batteries into the plant until they're empty. It's an evolving technology. They're expensive. We're going to be doing some battery storage on the Fresno, large Fresno solar array that we're developing.
Is it called something else?
They call it a microgrid.
Microgrid, thank you. It's a
microgrid's the technical term for those out.
So all of you that are watching, you
world.
can drop the name microgrid and sound.
So you want to sound smart, use the word microgrid. So what all a microgrid is a plethora of technologies: solar, fuel cells, batteries, any combination of the three.
You're basically creating a power plant.
You're creating
in essence,
a small
out of
power
the sun.
plant on your site, and you want to bring into that mix renewable sources like solar.
So let's turn now to automation because it kind of makes sense. We're
I love
running
automation.
energy. I know we're running a lot of energy
Talk
because
about
we're
sustainability.
Yeah.
Let's talk about automation.
So let's. How do we approach building? How do we think about what type of automation we need for a particular building?
Well, a lot of it is driven by the customer.
Mm-hmm.
Ideally, you want a customer that is predominantly full pallet, high
Mm-hmm.
turns.
Okay.
That is really what suits well in an automated
Mm-hmm.
system. So where we have customers that have that kind of business profile, we want to look to automate it or build a new building that can accommodate that kind of business.
So is there anything, I think a couple customers had questions about how do we become more suitable for for automation? What do customers need to do to be more suitable for automation?
Well, the easy answer is to pick in layers instead of individual cases.
Okay.
Because we've figured out how to automate our layer pick.
Mm-hmm.
So the more our customers order in full layers, we can then deploy some automation to automate
Handle that volume.
and not put our people in a freezer picking individual cases. We could use machines, we could use robots, we could use layer pickers to facilitate that case pick.
Right. And then, so, again, we had, a host of facilities that are conventional in nature.
Mm-hmm.
So, and we're trying to retrofit automation in some of those different facilities. So are there challenges or are there benefits that you can talk about in just having a retrofitted facility?
Well, there's both. There's challenges and benefits.
Great.
Obviously, the challenge is you have an existing infrastructure that you got to work on. You have columns, you have floor conditions, you have door locations, you have ceiling heights. The automation needs to work within the confines of the existing building. So
And within the confines of the existing customer profile, right?
And the confines of the existing customer profile. Whereas in a new build, you're basically designing the building around the automation system. With a retrofit, it's the other way around. You have to make the automation work within the existing infrastructure of the building.
So what are the benefits of retrofitting?
The benefits is throughput increase. These machines, robots, work 24/7 in a cold environment. So you get a productivity gain. They're pretty reliable. They're robust. And, we're putting machines doing the job of our people in environments that our people really don't want to be in.
Right.
So there's a safety component to it. There's a productivity component to it. And labor's becoming more expensive and harder to get. So it's kind of forcing us to take a look at automation as we look to build our new buildings.
And we're also trying to, again, back to customers and giving, customer service levels and, we're trying to give them a consistent service experience no matter whether we have labor challenges, energy challenges, we're trying to create that adaptability to move forward as the environment changes.
We want to be as flexible and seamless to them as possible.
Yes.
And still
so that sounds
make a profit.
Yeah, it sounds like kind of the theme of engineering is you're trying to give customers consistent service, but be flexible at the same time.
Exactly.
Yes, which is always a challenge in engineering.
And it's a challenge in automation because automation inherently is not flexible.
Right.
But we're figuring out ways to make it as flexible as
So
possible.
what have we learned through our automation journey? I know you used to have a crawl, run, walk thought process. Like what?
The crawl, run, walk. I'd say we're at a brisk jog right now.
We're speed walking.
We're speed walking. So what we've learned is it takes time. Where we used to be able to build a conventional warehouse in 7 to 9 months, it probably takes 18 to 24 months to build and start up an automated building. So we got to be cognizant of the time frame. Obviously, there's additional cost to build an automated building. So we have to be cognizant of the cash flows and capital required to support that type of infrastructure. Although there's less people involved with it, you need more technical people. You need technicians to maintain the automation equipment. You need operators that are sitting behind a screen, almost playing like a computer game, to operate the automation equipment. So there's new skills that we need to bring on board that we didn't have maybe 10 years ago.
So a lot of opportunity for existing
tremendous opportunity
employees to be able to pivot and
exactly.
take advantage of that automation and learn some new skills.
If computers and robots interest you, we have a job for you.
Wow. I mean, it's come a long way. So we talked a little bit about how, engineering has evolved over the past 5 to 10 years. Just in terms of the innovation in the industry, how have we evolved over the past 5 to 10 years?
Well, 10 years ago, we didn't have automation.
Right.
It was purely conventional. That's the way the industry was. I'd like to think that U.S. Cold Storage was an innovator and led that charge in embracing automation, embracing that technology. Yes. Lebanon was our first automated building. Now we have, McDonough, and we have Minooka, and we have another one under construction. We've brought into, just probably in the last 3 years, VNAs, very narrow aisle. They're turret trucks. They go much taller than typical deep reach trucks. Typically with that comes a series of automated pallet conveyance. So there's an automated footprint there. We're seeing a lot of advantages. Lake City will be our first automated or semi-automated turret truck, or as Larry likes to call it, multifarious.
If you happen to watch the Larry
multifarious
Coldcast, he does actually use that term.
Lake City will be our first multifarious design, but we have 3 others under construction right now. So that seems to be going forward. It's either going to be fully automated, like we're doing in Lowell, or it's going to be a multifarious design using some type of VNA with pallet conveyance going
What
forward.
Other types of innovation do you see on the horizon?
Data, AI. We're testing some pilots in a couple locations to help better control, I should say, our refrigeration systems.
Okay.
So all that data is going into a data warehouse. We have systems using machine learning and even artificial intelligence to optimize our refrigeration systems. And the importance there is our refrigeration systems use a lot of electricity. So it probably uses about 60%, 70% of the power that we consume as a company is just in that engine room, keeping the building cold. Yeah. So it's a lot of electricity. So if we can save 5%, 10%, 15% just in being better, being more efficient, it's huge.
That is huge.
And we're going to be deploying, I think, some of these systems over the next few years after we test them.
Is there other innovation that's going on in refrigeration?
Transcritical. A lot of it has to do with environmental refrigerants. We're getting away from the artificial refrigerants, R22s to R12s, the CFC based, to natural refrigerants. So CO2 has really become one of our primary refrigerants in addition to ammonia. The problem with ammonia is it's highly regulated and it's becoming more regulated. In some states, it's almost not even feasible to use. Right. So transcritical CO2 is one of the newer technologies out there. 10 years ago, it was mostly on the commercial side. It's becoming much more industrial, and we're using more and more of it where it makes sense to use transcritical CO2.
We know, I think the average age of a warehouse in our industry is 43, 44 years old. So there's often people talk about, these warehouses are getting older and they need to be replaced. But if what I'm hearing is, hey, we need to replace refrigeration anyway, are they easy to replace in those warehouses? Are they easy to retrofit? Some of these older warehouses?
Refrigeration systems are probably not easy to retrofit. You can improve components of it with more efficient components, but to replace a centralized plant, because it's kind of like the bones in your body. They're everywhere in that building. They're on the roof, they're in the engine room, they're on the dock, they're in the freezer. It's difficult to retrofit. We could retrofit components.
Okay.
The nice thing with transcritical, it's very modular. They come in these modules, they sit on the roof, they sit in your parking lot, and they can be upgraded, they can be expanded, and not take up the footprint that an engine room takes.
So for the new buildings, we're building much smaller engine rooms, if we're building an engine room at all.
If you build them at all, exactly.
Right, yeah. And so a lot of the new builds are probably don't have the size of the engine room that some of the other
You don't have that infrastructure, and there's a cost to that. probably $1 million of just infrastructure cost to build that engine room. And the other great thing about it is they're as efficient, if not more efficient, than the systems we currently use, and they use a lot less water, which is another sustainable aspect of these systems.
Yes.
They use a lot less water than your typical two-stage ammonia using evaporative cooling.
So you're actually helping out, again, from a sustainability perspective, reducing your water consumption.
Exactly.
Through new technology and refrigeration. What other innovations are going on in the industry?
Well, there's automation. One of the things that we just started to look at, and I think you're going to see more and more of it, is this more robotic layer pick system. It's called Apex.
Okay.
It uses a 6-axis robot to basically layer pick, where we would use a conventional forklift with a cascade attachment and the operator would sit in the heated cab. There's a system that's fairly new, and we might be one of the first companies to deploy it here in the States. Is this new Apex layer pick system. And I think the first one might go in Wilmington, but I know we're looking at using this system at 2 or 3 other projects that we have currently.
Are there any challenges because we are in cold storage? We're at 0, we're at -20. Is there anything that doesn't apply or that you guys have not been able to use, even though it's maybe deployed somewhere in ambient storage because we're in a cold environment?
Well, with robotics, you have to be cognizant of the environment that you're putting them in. When you get really cold, -20 degrees, like you would typically have with ice cream, things don't seem to want to work. People don't seem to want to work in that environment, let alone a machine. So you got to be very aware of the technology, the equipment that you're putting into those environments, because they are machines. They do require maintenance. So you got to go in there and maintain them. They require oils and greases that might not work very well in those environments. So being in a cold environment does limit what technologies you can deploy.
And from a process perspective, how you think about it, how you evaluate those technologies, right? Because you can't just say, oh, I want the new shiny thing that's up and coming. We have to make sure that we've done a pilot or we've tested it in that environment before we release it.
And it has to be rigorously tested for a period of time, because those new shiny things don't always work in a freezer. Right.
So, like I said, the engineering department, you said the engineering department has grown exponentially over the past 5 years. So what's your long-term vision for engineering?
That's a great question. I think we're going to become more entrenched in the strategy of the company, especially the growth. Sustainability is going to become a huge effort. I know we're talking long horizons, 2035, 2045, 2050. But I think sustainability is going to become more entrenched in every decision we make as a company. So I see us really becoming experts in that field. And Sarah and her team are doing a fantastic job in leading us down that path. And making it palatable so that we all understand what it is. Because if you said sustainability probably 2 years ago, everybody's like, wait, what is that? So now I think that's been socialized. Yeah. And everyone's going down that path. Majority of our customers are hammering and clamoring for sustainability information and data. So it's not just U.S. cold storage being a good steward of the environment. All our customers who store with us are also wanting to be good stewards, and we need to make sure that we're aligned, not with only Swire's goals and our own goals, but our customers' goals. Right. So your long-term vision is really, hey, we're going to be more integrated in with kind of the whole strategy of the business, and we're going to continue. I think you're going to continue to find innovative ways to be more efficient and have a more consistent service for our customers. I think that's going to be key. Efficiency is going to be key for us, whether it's efficiency in labor, efficiency in energy use, efficiency in water use. Sustainability and innovation is going to be the 2 key forces that are going to be driving us forward. And I know that you were part of the GCCA. That's correct. I'm on the SEBA board of directors. So is there anything that you've learned from them or that was interesting or exciting to you that you've learned through the GCCA? I'm excited that the industry in itself is starting to embrace sustainability. Oh, yes. I think it was kind of talked about, but not much action. I'm seeing it more and more. talked about. Not only the GCCA, but the IAR.
Yep.
They're talking about it. So it's becoming more important. More of our general contractors are getting more exposure to automation. So the methods to build an automated warehouse are a little bit different than a conventional warehouse. So we're seeing that expertise expand, which is good for us. So our customers, our contractors are starting to align ourselves with the vision that we have as a company, and the services that we need to provide our customers, which is, it's good to have. It's good to have it, as an industry.
They recently just announced some of the tariffs on construction, on construction materials coming over from China, right? So talk to me about what the challenges are that we face in construction and how we are, kind of how we're managing those.
Well, those tariffs are, for us, the biggest impact is going to be on solar panels.
Okay.
I think.
And steel? Yeah.
Steel's not so much.
Okay.
Definitely solar panels.
Okay.
Electronics, chips are all going to be very precious commodities in the near future, especially with tariffs. China probably manufactures 80% of all the solar panels used on this planet.
Interesting. Okay.
So you're starting to see some diversification of solar manufacturing outside of China here in the States. You're starting to see that with chip manufacturing. Believe it or not, a lot of chips go into our forklifts. They go into our battery chargers. They go into our compressor panels, our PCs, our phones. And you're starting to see diversification in some of those supplies that, geopolitically can become scarce in times of conflict.
Yes. Are there any other challenges around construction? I mean, for a while there, materials took a long time. There were some concerns about that. Is there anything you're seeing? Or
lead times are still a problem. Prices are starting to stabilize.
Okay.
And in some aspects, steel, we're seeing costs come down. Concrete costs are coming down. But there's still long lead times, still high demand. Forklifts have long lead times still. We're still seeing forklifts where we used to buy a forklift in 20 to 30 weeks is close to 2 years. Hopefully that changes. But pricing stabilizing, lead times still long.
Okay, that's interesting. All right. Well, is there anything else that you want to share with the Coldcast?
Well, I just appreciate this opportunity.
Yes.
I've seen a lot of people in here over the years, and I'm always wondering when it's going to be my turn. So I just appreciate the opportunity.
Yes. Well, engineering.
I like talking about engineering and the great things that we're doing because I have a great team. They work very hard. They're very dedicated to what they do, and the company would not be as successful as it is without the team that we have here in engineering.
I agree. And you guys are busy doing all sorts of things. You're kind of you're basically the construction arm of our entire company. So I think that's important. Yeah. It's sustainability, automation, construction. So we wouldn't be here without you guys.
Exactly.
So I think it's great talking to you. Thank you, Mike Lynch, for joining me.
Anna,
Hopefully he will join me again with some more information.
Let's hope, right?
Yeah. Yep. So we talked about sustainability. We talked about automation. We talked about construction and some of the new projects we have going on. So thank you guys very much for joining the Coldcast, and I'll see you next time. Stay cool.
Thank you.